Hey, this is a video from the Algebra and Surds topic, and we're having a look at simplifying algebraic expressions in this one. Let's have a look at a few key examples. This one is just adding like terms here, so we just got 3a plus 6a, and we just make 9a from that. Not too bad, those ones. We are able to add and subtract like terms. Got the same letter and power, so we're allowed to add them together. This one, 9k minus k, a lot of students think that's going to be 9 because you're taking away the k there. But one thing to help your brain there is to put a little 1 in front of the k. So 9k minus 1k would equal 8k if you think about it. So don't go and do that one too fast, that one. 8k. This one, we're only allowed to add and subtract like terms, so the a's can sort of talk to each other, but the b's are going to be listed separately. One thing I like to do for with students here is to suggest that it'd be good to box these. What happens is the sign that comes before a term belongs to that term, so if we box these terms with the sign that belongs to them, we'll then be more able to accurately use the correct plus or minus here, because a lot of students might think that we go 2a plus, because that comes next, the 5a, but that plus belongs to the 3b. So if we box them with the signs that belong to those, we can see that we've got 2a take away 5a, which ends up being equals minus 3a. Then that plus 3b belongs to the plus belongs to the b there. So careful with those. Putting a box around them, writing all over your exam paper or whatever, is the go there, because then you get the right plus or minus sign belonging to the right term when you join them up. And we're only allowed to join the a's there, only the like terms. This one, they're all m's, but two of them have got squares on them and one of them hasn't. So for the definition of like terms, you've got to have the same letter and power. So we're allowed to join the first ones and the second ones. We better put box around them. So I suggested that's the way to go in the previous example. So that plus belongs to the 4m and the minus belongs to the 3m squared. So whenever we use that, we'll be using the minus that belongs to that. So once again, it's the first and the third terms that we're allowed to join there. 4m take away 3m leaves us just with 1m, so we don't have to write the 1 in front there, but m squared for the squared bit. And then the other unlike term there, even though it's pretty similar, it's not a like term unless it's got a squared on it as well. So that's a 2 there. m squared plus 4m there. So we're allowed to join the squares but not the m's there. Okay, these are like terms, but it's not relevant for this. You're allowed to multiply the numbers together and the letters together. So we get 6 3s are 18. And y times y, that's where we get y squared. 2 is kind of indicating that there are two y's multiplying with each other there. This one, we've got a minus 2 times 6. We're allowed to multiply those front numbers together and we'll get minus 12. Now we've got a c to the power of 1 multiplied by a c squared, so we'd add the indices there. That's how we'd use that rule. Add the indices and we get c cubed. Because if we wrote it out together, like separately, we'd have a c times a c times a c. That's c squared is c times c. A total of 3 altogether there, so that's where we get the c cubed. This one, we're allowed to multiply the front numbers together. 8 4s are 32 from memory. And we have a look at the total of the m's. We've got a 1 m to the 1 and an m squared there. So if we add those two together, we get an m to the 3, or m cubed. And n's, we look at n cubed and n squared, gives us, when we add the indices, n to the 5. So careful there. 32m cubed n to the 5. Okay, 6d divided by d. I suppose we could have a 1 in front of there if that helped our brain. 6 divided by 1 is 6. I like to always turn these into fractions. Something is helpful for our brain to do that. 6d over d. And I suppose we could have the 1 there, but it doesn't really help in this situation. I'll change to a different color pen here so I can do some cancelling, because if we can find a number that goes into the top or a letter that goes into the top and bottom, we should do that. D goes into itself once on the bottom, and D goes into itself once on the top. And that pretty much leaves us with 6 times 1 over 1. It just leaves us with the 6 there. So the d effectively cancels out there, but it's much easier and safer to see that as a fraction rather than try and do these divisions horizontally. Okay, here we've got quite a bit to do here. We could find some numbers that can go into the top and bottom here, and I think 6, you can see that 6 goes into the top and bottom quite well. So 6 goes into the top twice, and 6 goes into 18 3 times. So that's the numbers handled. Now here we've got an a on the top and an a squared on the bottom. If we think about that separately, we've got an a on the top and an a times a on the bottom. So if we did a bit of cancelling there, a could divide into the bottom once and into the top once. So that would leave us with 1 over a as far as the a's are concerned. So that a on the top there kind of cancels out with the squared, if effectively just leaving an a on the bottom. Similar sort of thing would happen with the b if we thought of that bit separately. If we drag that off to the side here, we could say b times b is on the top, b squared, over b, and if we do our cancelling there, so don't be too proud to write these things out separately, and make sure you get them right. B goes into the bottom once and into the top once, so the b, you can see, sort of survives up the top there. So that sort of ends up being b over 1. So after we do all that cancelling, if we want to piece it all together again, the minus is still there on top, and we've got a 2 next. And on the top we have a b that survives, and on the bottom we have a 3 that survived the cancelling, and we had an a that also survived. I guess let me just get green here. It's really effectively on the b's. The b cancelled out on the bottom with the squared because we were just left with a b on the top there. So anyway, that's quite a lot to do there. We found a number that can go into the top and bottom. We carefully thought through the what would happen when the a's are written out and cancelled and the b's written out and cancelled. So quite a bit to do there, and we're just writing down kind of like the surviving numbers and letters as our final answer. This one, when we expand, we multiply the, we remember that there's a multiply invisible between a number and the thing that's beside it. That's true in algebra. So we're doing 4 times m there and getting 4m. We're making sure we multiply the front number by the second bit as well. 4 times 2 equals 8. That's just your classic expansion there. You're multiplying the front number by the first term and getting an answer, and multiplying that front number by the second term and getting an answer. This one, 2 minus 5 times x equals minus 5x, and then minus 5 times plus 4. A minus times a plus would be a minus. 5 times 4 is 20. Careful with that. This one, minus 7 times n equals minus 7n. That minus 7 is multiplied by a minus 2. A minus times a minus makes a plus. So we get 14 there. Careful with that. And here it's an interesting bit. Now the 8b isn't multiplying by this bracket, so what we'll do is, before we do that subtraction here, the order of operations suggests we do any multiplies and divides before we do any plussing and minusing. So we're going to expand that first and then see what we've got then. We'll write down that 8b as if it's still relevant. Will be relevant later. Okay, well, let's just expand this bracket. Minus 3 times a 4b is a minus 12b. And then a minus 3 times a plus 2 is a minus 6. Now we've got a couple of like terms we can use here. We've got the b's and the b's here. We've got 8b, take away more than we've got. So we've got 8 minus 12 is minus 4b. And the minus 6 isn't a like term with that, so we'll just write that down separately. So we've got to make sure we expand there before we kind of collect like terms. That's the way we would say it. And that's the end of that algebra and surds video. Lots of good key examples there to remind you of what to do. Hope that helps. See you next time.